Right. Good morning. Assalamualaikum warahmatullahi wabarakatuh, and welcome to week two of site planning. Um, last week I gave you an overview of the course. This week we'll talk a bit about the site planning process, and within the process there are five stages within the process. There's the pre-project, or also known as the pre-design. There's the site assessment phase, and then site analysis, and then the design phase, and finally there's the implementation phase. Sorry, um, where all the concepts, all the designs that were on paper are then put into practice. So let's get to it. So I'll first talk about the scope and the overall process of site planning. Um, Lynch Lynch believed that site planning is the art of arranging the external physical environment to support human behavior. This particular discipline lies along the boundaries of architecture, engineering, landscape architecture, and city planning. And site planning is practiced by members of all these professions. So if you were studying architecture, you would study at some point site. You would learn about site planning, how to choose a site, how to develop a site, and so on. If you're into landscape architecture, or if you're studying landscape architecture, then obviously site planning is a large takes up a large proportion of the course. Um, Engineering in general, some civil engineering especially, and of course city planning, urban planning, or regional planning. That's where we are at. It it underlines, or it highlights, the nature of site planning, the interdisciplinary nature of site planning. It is a it is a skill set that it is a skill set that is used in many built environment related disciplines. And further on, Kevin Lynch says that site plans locate structures and activities in three-dimensional space and, when appropriate, in time. Now, that's site planning in general, but what about site planning itself? What is its position? Where does it stand in spatial planning in general? Well, in spatial planning, site planning plays three key roles. First is it investigates and understands current site conditions, and it does so using both measurable and immeasurable criteria. Measurable criteria is obviously tangible items, physical condition of the land, how how large is it, how large it is, the size, the area, the contours, soil types, etc. And then the intangible aspect of understanding site conditions is to understand the aspects of population, or demographics, population numbers, population density, local culture, and etc. The second key role of site planning is to assess site or location feasibility. When you conduct a feasibility study, then some of the analysis that you will some of the analysis that is generally done in site planning carries over to the or contributes to the feasibility study, and it helps determine the suitability suitability of land for development. It helps determine whether the situation or whether the land is compatible with different aspects of legality. It helps assess through the availability and the capacity of the infrastructure, etc. And of course, what would a feasibility study be without the careful consideration of sociocultural conditions to help determine the type of activities to be conducted or to be held on the site. And finally, site planning. Site planning's other key role is to, of course, develop a site plan. Developing a site plan not only entails the formulation of the site plan, but it includes the development of a comprehensive master plan, including business plans and or strategic or action plans to go with the master plan. The supplemental plans, as I mentioned here, the supplemental plans that I mentioned here generally involves generally contains the explanation and or strategy and or specific strategies in dealing with special traits or characters of a certain site, and how they would go about dealing with those traits. Right. So, if you were to put the site planning process into a flow chart or into a diagram, then the diagram would more or less look like this. Here we see here we see there are several component or sorry several stages of site planning. So it begins with programming and or site selection, and then moving on to site inventory, where you list or you make an inventory of the physical traits, physical features of a site, and the biological features of a site, and the cultural aspects and the cultural features of a site. So there are three big containers there. And of course, perhaps there are other aspects that you might need to take into consideration. Then you can just add another category to this slot right here. And then and then from the inventory process, we have all this information, we have all this data. But in order for that data to be meaningful or for it to be useful as planning or design information, then we take the inventory, we take the items in the inventory, and we put them through site analysis. Now, the first three stages can be can be a bit cyclical. So sometimes the programming and site selection, sometimes when you come up with a site program, or when you have a site and then you do a site inventory, the site inventory may inform you early on whether the programming that you have done is compatible with the features and characteristics of the site. Other times, maybe the from the site inventory, um, you get an indication that the programming is okay. The site seems okay, but when you conduct the site analysis to determine to further determine or to confirm site suitability, um, you might find that you might find that some parts of it or some features are incompatible, or maybe your program may be incompatible with some features of the site, and so you might have to go through you might have to go back again and rewrite your programming or rewrite your initial idea, um, and sometimes and sometimes if you push it to the extreme, then if the site analysis says no, this location or this site is incompatible with what you are about to do, then you might need to select a new site. But once that is out of the way, once you have determined that your site is suitable, that the program or the idea or the activity the activity that will be held there is suitable, is okay, then you move on to formulating a conceptual design, and then further develop the you further develop the design up until it's a final draft, and then um, you start to develop the construction documents or construction plans, and then of course you implement the project. You take these documents and you put them into practice, so to say. And let's have a look at each box separately. Um, First and foremost in this site planning and the site development process is, of course, the project initiation. Somebody has an idea. That's what this stage basically says. The initiation can come from the public sector, government authorities. It could come from the private sector, businesses, uh, Walt Disney and Universal Studios, for example. And then to to put this idea, to put thought onto paper, and to make the idea come into fruition, the project initiator, can choose to partner with a firm that they've worked with before, or they could choose an entirely new partner, um, who is who is a who comes from a reputable firm, of course. And if the initiator is from the public sector, then then uh, there are other preparations to consider, or they need to take or they need to do other preparations before moving on with the project. Um, it could be that they conduct a request for qualifications, or RFQ, or a request for proposals. So they have the idea, and they go through the procurement process, or they could simply issue employment contracts and terms of references, which include scope of work, work schedule, budget, and schedule for disbursement of funds, or um, in in our language, we know the disbursement, or the schedule for disbursement of funds, as termin. So if it's a private sector, then there's not a lot of red tape to go through. If the initiator is from the public sector, then to put that thought onto paper and into practice, it it, it, it entails a few more layers of red tape or bureaucracy, as with um, as with any other government bodies. So, but this is just an illustration of how a project initiation usually takes place or could take place. And once you have an idea of what you want to do, what you want to develop, what you want to build, then um, the next step would be to select a site and to sort of program or to sort of detail um, or sort of develop the initial thought. Um, there are some uh, not processes. There are some aspects to consider when you select a site. The situation may be that the client that you're working with already owns a piece of land, and then they determine what will be developed or what will be built. Or maybe the client has a specific target, they have a specific idea, and then they look for a suitable land to execute it, to execute their idea. Um, for example, your client might be thinking, I want to build a theme park, and but I don't have the land. I don't have the land to develop my theme park just yet. I don't have a site, and I don't know the location of the site just yet. So you may have to help your client determine a suitable site at a suitable location based on what he wants, based on what they want to, based on what they want to develop, theme park, a hotel, or resort, or whatnot. And that's the initial that's the initial step, or that's an addition, to the project initiation bit. um, and now onto the site planning itself. um, the site plan is basically the planning and provision of circulatory lines, and the placement of buildings. That's what it basically is. However, when programming for a site plan, um, extra emphasis or extra focus should be, or extra attention should be paid um, to focus on conservation, um, perhaps even the restoration and management of natural areas or natural features. Um, it is lately it is becoming more and more important, or more and more crucial, to focus on conservation, restoration, and management of natural areas rather than the built areas, or the engineered areas, simply because we need to orient our ideas, we need to orient the development, and align them with the sustainable development goals. If you want if you want your site plan, if you want your site plan and your site program um, to work to work in the long run, or to be sustainable, and to maintain the balance between the built and the natural environments. The site program sharpens project objectives and determines functional requirements. Um, so when after the initiation phase, in during the programming, you would come up with, or you would formulate project objectives that are attainable, that are measurable. Um, that way, this whole project is then broken down into smaller and more manageable components. and that is reflected. That would be reflected later in the in the in the overall site plan, in the master plan, and the business and action plans or strategic plans. And the functional requirements of a site includes land use plans and the area, or how big or the size of each land function, and the and the spatial relationships between each and every function. So I'll have a we'll dive further into that a little later on. And then finally, the site program itself can either be prepared by the client or by the client themselves, or the site program can also be prepared by the client with the help of a planning professional. Sometimes, well, actually, most of the times, the site program includes initial market analysis or demand study or user demand study, as well as taking into account previous studies. Um, in the example that I mentioned before, if you want to build a theme park, then of course, before dumping your money into developing the actual theme park, you would of course analyze the market. Who's this theme park going to be for? Is there a demand for this theme park? Otherwise, if there's no demand, as fantastic as that idea may be, it may not be feasible to continue with the project, and you might have to go back into programming. You might have to change the idea. Instead of a theme park, you might instead you might build a hotel, or or other things. You might build a mall instead. So once programming is done, we move on to site selection. And in the diagram earlier, site selection and programming are at the same level, and the arrows go back and forth. So sometimes you select the site and then you develop a program for the site, or you have an idea, you develop a program, and then you look for a site. However, in site selection, there are three three major considerations, or you choose a suitable site at a predetermined. You may choose a suitable site at a predetermined location. For example, I want to build my hotel somewhere in Bali, and then you choose a suitable site in Bali. Or I want to I want to build a mall somewhere in East Kalimantan, and then and then you try to choose a suitable site there. Uh, or sometimes the site has been determined based on land ownership. If your client already has a piece of land somewhere, then that's it. You just need to get with the program. Um, or the site can be designated in a more macro plan, as in um, you have this idea, you have this concept of building a hotel or building a resort, and then you choose a site based on local or regional master plans, or local or regional development plans. Rencana Tata Ruang, for example. You have a look into that, um, which locations are um, potentially doable, or have the development potential, and then you choose your site from there. Of course, when you choose a site, every idea or every program have different requirements. For example, if you select a site, or if you conduct a site selection for housing, for housing development purposes, then the site needs to be situated in accordance with the needs of the population for the type and class of development that has been planned. Um, and perhaps you need to consider whether the site is hazard free, or you need to consider whether the site is situated near an environmental hazard. For example, if you're building near bushland area, then you might risk exposing the residents of that housing development. You might risk exposing them to future hazards, or to future disasters, bushfires, for example. Um, you might need to consider whether there's a protective area or a buffer, um, especially when the site is situated near a major artery, or near a railroad, or um, even near or at a distance to, or adjacent to, an industrial estate, for example. Um, of course, you need to consider the ease of access in terms of time and cost, and finally, you need to determine whether the site is fairly competitive in terms of general attractiveness. Um, Within the site, what's the area of the site, and how can you subdivide the site, and what size of plots can you provide there, and whether and then have a look at have a look at the competition. Are there any other housing developments around my site? Um, and if there are, what size houses, or what size are there? What size are how are their what is their plot sizes? Am I going to provide bigger plot sizes, or am I going to provide smaller plot sizes, and so on? That was an illustration of site selection for housing development. This time, it differs so much from site considerations for a city park, for example. A city park needs to be accessible, and it needs to be visible from it needs to be visible from strategic points of the city. Preferably, it has a view, or it has a good panorama. The fancy word for that is visual appropriateness. It needs to have a visual appropriateness. Um, permeability or permeability or patterns of movements and paths of and paths towards or through the area, as in it has something to do with accessibility, actually. Um, but not only does the park need to be accessible, but maybe the park um, maybe the park works as an intersection, or as a junction, or as a sort of hub. If you walk through the park, you can actually go from A to B by walking through the park. You can reach your destination by going through the park rather than around it. So that's what permeability means, basically. The city park the city park site needs to have a comfortable microclimate, as in maybe the relative temperature compared to other parts of the city needs to be a bit more comfortable, or needs to be lower than other parts of the city. Or then again, the microclimate changed or modified depending on the selection of vegetation, um, and the size of the park and whatnot, and what other features and other features that you decide to add in the park. If possible, it should have an attractive topography. If your site is flat, then that's okay. But maybe just to make the park more interesting, rather than leave the site flat, you might want to elevate certain sections of the park or certain sections of the site, to give that to give a more attractive and a more engaging experience when exploring the park and such. Um, preferably the site already has natural features, vegetation, animals, lakes, lagoons. Perhaps there's a stream or a creek that flows through the site, and finally, overall ecological value. Um, so ideally, if you want to develop a city park, then you would choose a site that has predominantly natural features. However, sometimes if you're building a park in a city or in the heart of a city, then such natural sites may be very scarce, very rare, or even non-existent. You might need to remove some structures, remove some buildings in order for you to build this park. Surabaya has done so by removing a lot of by normalizing a lot of the boulevards, removing removing uh, micro pump stations, gas stations, and generally rehabilitating certain areas, um, to make it a more attractive feature of the city. An example of a city park that uh, that had to remove hundreds, if not thousands, of residents in order to build it is Central Park of New York. Um, before it was a before it was a lush green carpet of vegetation and landscaping. Um, that particular part of New York was human settlement. Basically, it was that housed thousands of people, um, and they had to raise that housing. Sorry, they had to raise that settlement and displace thousands of people, um, to provide the Central Park to build Central Park, which is a rather sad story, come to think of it. Um, so once you have your site, once you've determined where you're going to build, you have a site, you have a location, you then need to then you then need to start to um, develop the idea, and first and foremost, you need to make an inventory of your site. Um, the site inventory process itself um, is an attempt to understand the relevant contextual factors or attributes that that make the site. There are four determinants to consider when you conduct a site inventory. Um, what is the proposed site use? Uh, what is it going to be used for? And what are the existing on-site and off-site conditions? Because of course, when you're developing a site, you're not only you're not only affecting your own site, you may be affecting the area around surrounding the site. Another determinant to consider is whether there are certain requirements or there are special permits to attain or special approvals. And lastly, how much is it going to cost to conduct this site inventory? How much is data collection and data analysis going to cost, and so on. We're not going to cover the cost of data collection and analysis in this unit, but we'll focus more on the proposed site use and the existing on-site and off-site conditions, and we'll explore site inventory further in our next meeting. So just to recap, the site inventory process produces, well, if you want to produce a good site plan, then you need to understand the relevant contextual attributes, and you do so by conducting a site inventory. Here's more or less what a site inventory can look like. Categories, subcategories, attributes. It's basically a table where you, it's basically a table or a tabulation of attributes or characteristics or features that that you take from the site. It could be physical. You can divide the categories into physical, biological, and cultural, or you can add more categories to it, whichever suits your needs and whichever suits the particular site that you're developing. And then you move on to subcategories and then attributes. For land, maybe you need to determine its bearing capacity, its porosity, stability. For the topography, the elevation, slope, and slopes and aspects, local vegetations, local species, whether there are certain habitats for local species, and so on. And legally speaking, you need to consider the land status, land use, and land use of your current site, and the land use surrounding the site. What's important to remember is a site inventory is not site analysis. Site inventory is simply the gathering of information, the gathering of data. Site analysis is where you turn the data, the information that you gather, into planning information to help you determine whether the site is suitable for development or not. For those of you late to join, here's you can scan the QR code to mark your attendance for today's session. This is an example of a site inventory that illustrates slope, or that documents the slopes and the elevation within a site. I'm going to use the same site throughout this session, so that you can have a grasp of how the site is developed from its natural state until the end product itself. In this map, it shows, as I mentioned, it shows the slopes and elevation, and from there you can already determine, or you can already see the slope suitability. So the lighter the color, the more the flatter it is. And the darker the color, the steeper the slope. Um, here, the words are too small, but it more or less says that the lighter slopes or the lighter colored slopes are most suitable for development of any feature. And then the darker slopes, they are severely they are the slopes are too severe for development, and therefore either you need to avoid development in those in these dark green areas, or you might need to treat the slopes in such a way so that they're more suitable for development. And this is just the slope analysis. Bit further, this is the vegetation and wildlife analysis of the same site. um, within this map, you can see that you can see that the planners or developers have mapped out where the main cluster where the clusters of vegetation where the clusters of existing vegetation are, to the northern side, to the southern, eastern, and to the west, and so on. And here we have here we have an explanation of the types of vegetation there is, mixed forest association, and so on. There are some vegetation notes, and here's an inventory of the sort of wildlife that are available, the sort of wildlife or animals that live within the site. There are certain species of birds, there are certain species of mammals, and reptiles and amphibians. And when possible, you might need to take note in your inventory, and perhaps even plot them in your map, as to where these species are found, whether the birds are found here or predominantly in this area, and so on. Next up is the soil analysis. And in this same area, but it looks totally different, because this time we're looking at soil types that are the soil types of that site. There's a soil description, and and a description of each soil's characteristics, bearing capacity, porosity, and so on. And from this, and when you consider this, you can already already sort of get an idea of what types of buildings, what types of function you can develop on the site based on the soil types and so on. And when conducting, but this is just the inventory, the inventory stage of this is just the inventory stage. If you take soil inventory further, you may end up producing some sort of soil suitability matrix. The white boxes are for high suitability. The checkered or the black and white boxes are for medium suitability, and the black boxes are for low suitability. But that's for that's for later, for the for the site analysis stage. And then this is an analysis of of its hydrological of the site's hydrological features. It takes into account this this sort of analysis um, is strongly correlates with the slope inventory, the slope analysis, slope inventory and or analysis that you conducted earlier. Um, you can it's basically just to give you an idea of potential water runoffs or potential water catchment areas. Um, and I think, well, of course, the steeper the slope, the faster the water will run off the surface. And if you go back to the soil map, then the soil map kind of gives you an idea of which areas have quicker quicker absorption rates than others. In this hydrology map, the planner has identified major ridge lines, minor ridge lines, and perennial drainage ways. There's intermittent drainage ways, ephemeral drainage ways, and then there's some sheet drainages, and the location of ponds. And this is what I meant by water catchment areas. Here it is expressed, or it is here it is expressed as seasonally wet areas. So here's a seasonally wet area there, here, and along this perennial drainage way. So at a glance, it seems that any amount of rain to occur on this site, then water would generally, when most of the water would be collected along this perennial drainage way. Here's another sample of this is a sample of the existing conditions. Apparently, this site has a bit of surface mine operation within the site. This is just an inventory or a description of where the existing vegetations are, and a description of this circulatory aspects such as gravel roads, streams, and the utilities. Apparently, there's a power or phone line that runs through or along the site. Or there's a high voltage power line that runs to the north, that runs across the north of the site. So this is just the existing conditions and the site border. Of course, you have to determine the property line as well. Some description on access, description on geology and the current activities that take place on the site. But that's just an illustration of the sort of site inventory you would expect to produce in not just in this unit, but if you decide to pursue a career in site planning and or landscape architecture. So ideally when you compile a site inventory, it's not just a table of descriptions such as this, but you would ideally map those features to give yourself and to give your client a much clearer picture, or a much clearer understanding of what you guys are dealing with. And so, moving on from site inventory to site analysis. While site inventory aims to collect data for planning, collects data for analysis purposes. Site analysis transforms that. Site analysis transforms the collected data into planning information. So site analysis, first and foremost, aims to collect data for planning purposes. So site inventory collects data for analysis purposes, while analysis purposes collect and or generate data for planning purposes, if that makes sense. And then another aim is to evaluate the land suitability according to the target project or activity activity that will be carried out on the site. It also tries to identify issues that have the potential to create project setbacks, or maybe some certain issues that might require further study or further analysis. Of course, lastly, it needs to identify any administrative requirements, such as the requirement of certain development licenses or certain permits and such. Site analysis, if you consider the whole site planning process, the site analysis is actually a key, or if not, it is arguably the most important part of site planning and development. If you get the site analysis process wrong, then you might generate the wrong data, and generating the wrong data might lead you to false conclusions. It's not suitable, but it actually it is not suitable. But because of the errors in data collection and in data analysis, you might say that oh, the site is suitable, it's fine. So it is a very crucial part, if not the most important part of the whole site planning and development process. And although it's the most important part, sadly, some clients decide to limit the scope of analysis for the sake of saving project expenses, because site analysis takes time. Site analysis takes in a lot of resources, and it can get very, very expensive. Yeah, Russ just reinforces the idea of site analysis being the most important step in the successful site design process. When you conduct site analysis, you may conduct an analysis of the of the attributes. Sorry, you may conduct an analysis of the attributes separately, but then in the end, you put the analysis results together, and from the interaction between these attributes that you've analyzed, you come up with what is called a land suitability analysis or land suitability map. Which parts of the site is more suitable or most suitable for development, which are moderately suitable for development, and which are not, or have low suitability, or up to a certain extent, not suitable for development. If you put the site analysis process on the map, then it would more or less look like this. This is a composite analysis. This is a map of a composite analysis of the various aspects that we have looked at previously. You may remember there was a site inventory, a hydrological analysis, a soil analysis, and vegetations and whatnot. And when you overlay those maps, you get a composite analysis that determines the level of suitability for development. Here, the planners have divided the levels of suitability into four categories: high suitability, moderate, low, and severely limited suitability, as in avoid at all costs. Now, it is important to remember that the site analysis process is an interpretive process, in which some information is obtained from another set of information or data sets, the inventory that you built, and the site analysis is used um, to determine or to project future land uses. So you're kind of you kind of have this um, forecasting role. You forecast what's suitable, or you project what's suitable for development, what's not suitable for development, and so on. Um, the second thing to remember is that the key to site analysis lies in how the information is understood and used, um, not in the completeness of the data set itself. You may conduct a complete or a very thorough site uh, you may conduct a very thorough site inventory. Um, you've you've listed all the types of vegetation there that is existing. You've identified all the invasive species. Measured you have measured every slope and mapped out every contour line. But all of that information is useless if you if you do not understand or if you can't use the information uh, to produce to produce something like this composite analysis map. So once again, it's an interpretive process, and it hinges on how you understand. It hinges on how the information is understood and used, not how complete the data set is. You may have an incomplete data set, but if that data set provides you with enough understanding of the site, of the characteristics of the site, then not a problem. Um, some uh, some attributes that may affect land selection and land development. Um, you may this is more this is more to the hazards and potential setbacks that you may face, or potential disturbances that may arise from the site that you are developing. Um, if you look at major setbacks or major potential setbacks, other than soil conditions, the availability of groundwater, erosions, swamps, and extreme slopes. Um, if your site happens to be a historic site or an archaeological site, um, it it can have a twofold meaning. On one hand, you have yourself a very valuable site. This is a historic site. We can market it as such. But on the other hand, this is a historic site. You shouldn't be developing it you shouldn't be developing it. Um, or this is an archaeological site. Um, don't do anything to it. Um, one example of this situation is the perfect example of this situation is Rome, for example. Um, it has taken them more than 50 years to develop their subway network. Why is it taking so long? Because every time they dig, they they would they would come across an archaeological site or a historic site, and then the government shuts down the development and decides to do an archaeological dig instead. And then they say, all right, well, let's move the station to another place. And then they move to another place. They go about digging, and they find another archaeological site, and the development is halted. So that's an extreme example of archaeological and historic setbacks. Um, you might have inherent threats. You might have inherent threats on your site. For example, toxic waste. Um, for for an example of how toxic waste may affect a site or may affect the areas surrounding the site. Um, you guys should watch the movie Dark Waters. That that is a very good description of how an industrial activity may impact the overall health and well-being of a community in both its natural setting and the people that live within the community. Other other hazards to consider: floods, storms, typhoons, um, potential potential earthquakes or landslides. Is your site situated near an active volcano? And other fire hazards. So these are attributes that may hinder site development and might in fact detract you from selecting the site in the first place. There's just too much hazards. There's just there's too much potential setbacks. Let's go find another site. Um, the results of a good site analysis can encourage and facilitate collaboration between various stakeholders and various professions involved in the project. Um, so within the site analysis process, you do have to consider the law. Are there any rules and regulations that you might bend or in fact break when you develop the site? And of course, from the planning discipline or from the planning profession, they conduct a site plan review. The landscape architects might produce the site plans for the planners to review. The architects come up with the building design for the landscape architects to review and the planners to review, and then the engineers might have to treat the site, or they might come up with strategies on how to remediate or treat certain features of the site to make it more suitable for development. And then people in real estate, they will know what to do in terms of the overall land development. So, as I said, results of a good analysis can encourage collaboration between various professions that are involved in this particular project. Once site analysis is done, you have determined land or site suitability. Then you move on to developing the conceptual design. So at this stage, you have the site program. You have the site program. You have the idea. You have an idea of what you want to build. and on the other hand, you have this you have this you have the land suitability map, or the land suitability matrix, whatnot. You have an idea of what you want to build, and you have an idea of where you can build and where you can't build on site. So basically, the conceptual design phase is the process of integrating these two components, integrating the site program with the unique attributes or features of the land to be developed, and it is at this point where you start to arrange the various functions on the land to be developed. Simply put, a conceptual design would lay out the functions as such. You may begin with producing functional diagrams that describe the relationships between program components and activities. At this stage, you and your team may not have a detailed description of the activities that are that you're going to have in your site, and so you may just simply put or categorize the activities as public, semi-private, or semi-public activities, and private activities. And you may have, you may or may not have a supporting activities, such as service activities. How would this functional diagram look like on the map? Let's go back to that. Let's go back to the same sample site that I have. Here you have a rough idea of the functional diagram, of how the functional diagrams will look like on when you put them on the map. And again, these are just functional or conceptual diagrams which describe up to a certain extent the certain features that are certain features that are on the site, and maybe maybe certain crops, or certain this is the red, sorry, the red ones are shooting ranges. So this is a plan to develop a farm on the site. So the green ones are the woodlands, orange for crops, red is for shooting area, and the blue ones are for ponds. And you kind of get the idea, or the functional diagram, or the conceptual diagram, gives you a rough idea of where things would be, and how people would and how visitors would navigate, how visitors and users of the site would navigate through and around the site. Here are the two entry points, and from the entry points there's a main sort of spine leading to recreational facilities, and from the recreational facilities, then visitors can go and visit other attractions or other functions. As you can see, or roughly see on this on the center of this map, the recreational facility does not have a direct connection or direct access to the shooting range, maybe for safety purposes. So visitors who want to access the shooting range have to go through the woodlands to access the shooting range. Again, perhaps for safety purposes. And of course, you might not you might not just produce you may not just produce one conceptual map. You may produce other alternatives, and to find out which of these alternatives are are ideal, or which one of these that work. This is alternative one, where recreational facilities have direct access to shooting ranges and basically have direct access to other functions. No, actually, no. Recreational facilities have direct access to ponds and shooting ranges, but no direct access to pasture, crops, or woodlands. In this concept, and of course, each concept. Sorry, coming back to that. And of course, each concept has its advantages and disadvantages. In this one, the planner says the advantages of this layout or of this configuration is that there's good access to centralized recreation facilities, and that the shooting range is convenient to access from the recreation center, and that grazing areas, or the grazing areas with the pasture and the crops are situated away from the shooting range or the hunting grounds, and therefore thus reducing the risk of accidental shooting and such. Um, some disadvantages like limited distribution of pasture areas, emphasis placed on crop production, and that the land use is not balanced. So let's move on to the second alternative. With this configuration, the planner determines, or the planner thinks that there's a good even distribution of pasture areas. Of course, from the entrances, from the entrance and the main circulation area, you have pastures to the north, and you have pastures to the south. So yes, a better or even distribution of pasture areas. There's a good access to ponds from pasture areas, which allow animals direct access to water, and the recreation facilities are very convenient to access from the entry points. However, the shooting ranges are situated too close to pasture, and there's a very poor distribution of crop areas. In fact, there's only one crop area here, and that the recreational facility is separated from much of the site, which you can see. This is quite a long walk from the western entry point to the recreation facility. The recreation facility is very close to the eastern entry points, but it is basically sort of segregated from other parts and functions of the farm. The planners determined that concept number 3 is the ideal concept because there's a good ratio of land use areas, so they've maximized every inch of the land, and there's an even distribution of different land use types, centralized recreation facilities, and the shooting activities are situated away from pasture, although there is a direct access here, and there's still adequate or good access to ponds from the pasture. You may end up developing more than one, more than two, in fact, or more than 5 concepts, and it is, and then of course it is up to you to develop, and of course it is up to you to determine whether which option is more suitable for your needs and such, and yeah. Now, after you've laid out the functional diagrams, you determine which configuration is most ideal. Then you proceed with the design development. Um, and at this point, the concept plan is further developed. Each component, each each component, each land use, or each activity or function is then assigned a physical form. This is where you start to determine what sort of buildings you want to put there, what shape it is, what's its size, and what maybe even up to what materials you're going to use. Although we're not we're not really going to go that deep. It's the basic shape and size is enough in this unit alone. And this design development is generally expressed through a design documentation, which includes floor plans, elevations. Elevations is tampak, so front, back, side elevations and such, and then sections or potongan, and three-dimensional illustrations to give a good and thorough visualization of what the development will look like in the end, or the end product. As with the conceptual development, the design phase um, may have different. The design phase may produce different iterations or versions of the concept. Here you have a preliminary design or a preliminary master plan of the farm. Um, so I take it that okay, this is where the recreational facilities are situated, and these are the shooting ranges. Um, Obviously, the woodlands, the fallow areas, crops, and pasture grounds. So this is basically this preliminary master plan is basically an expression of or the design expression of the previous functional diagram that we saw. And if we take the preliminary design further, then we end up developing this the final master plan of the site that we want to develop. In this case, it's a farm. Recreational areas, shooting ranges, and then this is a combination of pasture crops, and watering ponds for the animals to graze upon. So that should give you an idea of how a site is developed from beginning to end. Although from beginning to end up until not beginning to end, but from beginning up until the master plan itself is developed. Once that's developed, the next thing to do is to implement the project. So the master plan would then be translated into construction plans and construction drawings, and from there they would draw up the specifications, the materials that they would use, the construction techniques that they would use, and so on, etc. Basically, right up until this stage, the planner and the landscape architect's roles are finished. However, uh, when I say that their roles are finished, that does not mean that their involvement in the project is um, is done or is finished. So, what is the role of a planner at this stage? Well, they can be the project, they can be overseeing the project, as in they would supervise the project along with the client, just to make sure that to make sure that the plans and the drawings are developed and executed accordingly. Ah. And finally, I think I think I have uploaded these two books into Classroom. Allow me to double check a little later on. However, the site analysis book from by Legros Jr. is a very comprehensive is a very comprehensive book for you to ponder and read. And then Russ's book of site planning and design complements Legros' book. So these two, yeah, again, I should have uploaded them. I think I have uploaded them in Classroom, but allow me to double check a little later on. So, as promised, in the next meeting, we will talk about how to go and we will talk about how to go about and do site inventory stage, and that and how to perhaps even search the spatial policies and regulations, and determine the land use or existing land uses, determine environmental identity, and facilities and infrastructure. Now, normally what I would do during this site inventory site inventory discussion is that I would ask you to draw up a table and go out and explore the areas surrounding the department, and create an inventory of the urban and regional planning department and the surrounding areas. However, I don't have I don't really have an alternative to that at the moment. So, if any of you have any ideas of how we would go about and conduct this site inventory exercise, you're more than welcome to suggest any ideas. But in the meantime, if you have any questions or comments regarding the site planning process that we just talked about, you're more than welcome to unmute and speak. Okay. If there are no comments or questions, I know this is very early. This is still very early in the morning, and perhaps this is a bit too much. But again, as I mentioned, if you have any ideas for on how we would go about doing this site inventory exercise for the next meeting, please let me know. Otherwise, thank you very much for coming to this early session today. Thank you very much for your attention, and I will see you all again. I will see you all again next week. Have a great day, and happy happy St. Patrick's Day.